All right, third example, and then we're going to stop talking about inventory. We're going to set this one up very, very similarly. Okay. And then we'll look at some other stuff as well. So what should the inventory policy be from the previous example? If the sales of frozen orange juice increase fourfold, but everything else stays the same. So the demand is going to increase by a factor of 4. So instead of selling 1,200 cases per year, we're actually going to sell 4,800 cases of frozen orange juice every year. So let's kind of look at things. We'll also kind of look at things from a different point of view. So in example 1 and example 2, we sort of derived this problem in one way. And now we're going to derive the problem a little differently. Okay, let's say we order trying to remember the order R times for X cases. Let's use 2 variables here. It's going to make the problem a little bit easier, I think. All right. So the cost function, right, is still going to be our carrying cost plus the delivery fees. Just like before, the delivery fees are not so bad, right? It's $75 per delivery. So if we're ordering R times, right, it'll be 75 times R. That's our delivery. Those are our delivery fee. $75 per delivery, and we're doing R delivery. So just multiply them together. Now the carrying costs are a little bit harder to get. Remember, the carrying cost from the first video is going to be the average number in stock times our $8, because each one costs $8 per year. Okay. So it's going to be 8 times that average. And remember, the average is going to be 4,800 divided by 2 and X. Now, where did this come from for the average, right? Where it comes from is kind of what we looked at in the first example, right? Where if we order once, we're just averaging 48, or we're averaging half of 4,800. If we ordered twice, then each order would be 2,400. Oh wait, I think I'm combining things. I actually think I made a mistake here. Let's erase this part real quick, and then we'll erase this part, and then we'll talk about it, right? If I'm ordering twice, then each time I'm ordering, this is our X value up here. Whoa! Ahem. This is our X value up here, right? X is, I was approaching this the same way. What we're kind of showing a different approach here. X cases, right? So if we order once, it's going to be X divided by 2, right? This is our X value. This is how many things we're ordering at a given time. Whereas over here, if we order twice, then we're ordering 2,400 per each one, and we're averaging half of that. If we order 3 times, then we're ordering 1,600. All right, so what really matters is how many cases we're ordering at a given time. And then we divide that by 2. There we go. And this looks much nicer. All right, if every order has 4,800 cases, then we average half that. If every order is 2,400 cases, we average half that. If every order is 1,600 cases, we average half of that. All right, so this is our average right here, and this is the cost per case per year. So what's different with this approach, the approach that we're using in example 3, is that now we have 2 variables, okay? And again, you can forget this example and just do 1 and 2 again. You can use that earlier approach. There's kind of 2 different approaches that the book will walk you through as well. All right. So what do we have here? If we simplify this, we'll get 4x plus 75r. And we want to minimize this function. Unfortunately, we can't minimize it right now, right? We can't take the derivative here because we have 2 variables. This is where we really tie into the previous section, 2.5. We need to use a constraint. This right here is called our objective function or our cost function. And we need to use a constraint equation to remove one of these variables. So the constraint here is that we need to order 4,800 cases per year. So the number of times we order and how many each order is, those should multiply to 4,800. That's our constraint. So x times r should be 4,800. Right? If each order is 100 and I'm ordering 8 times, that would be 800 cases, right? You just multiply them together. So that's our constraint. And what we're going to do is solve for one of these variables. Remember back to 2.5. Solve for which one of these variables you want. I'll solve for x. Divide both sides by r. Get 4,800 over r. And we plug that in for x. We plug that in for x. Woo, it's been a long day. We get our cost function now with only one variable. 4 times x. And x we said was 4,800 over r plus 75 times r. And now we have a function of a single variable. We can take the derivative and we can minimize it. So this is just another way of coming up with the cost function. This is not a new problem, really. It's a little new, but it's just another approach. Let's simplify this cost function and take the derivative. 4 times 4,800. That's 16,000 times 3,200. That's 19,200, I think. Use a calculator. Don't try to do this. And we'll take the derivative and set it equal to 0. So c prime negative 19,200 divided by r squared plus 75. We want to set this equal to 0 again. We'll do that on the next page. 0 equals negative 19,200 over r squared plus 75. We need to get rid of our fractions, so we're going to multiply both sides of the equation by our LCD, which is going to give us 0 is equal to, again, we have to distribute that, negative 19,200 plus 75 r squared. Add 19,200 to both sides. Divide both sides by 75. You get r squared is equal to definitely that number, which I totally know. Let me think about it. It's 256. So r, the number of orders we're going to make in the year, is no longer 8. In example 2, right? If we only had a demand of 1,200 cases, we ordered 8 times, and each order was for some amount. Now we're ordering 16 times in a year. 16 orders in a year. So if demand quadruples, the number of orders we have to make doubles. All right, let's see our new value of x. How do we find x? Remember, x is 4,800 divided by r. So divide that out, and you're going to get 300, I believe. So 300 cases, each order. So what is this problem asking us to do? What should the inventory policy be if sales were to increase 4-fold, but everything else remained the same? So in the old example, right, in example 2, we said 8 orders of 150 cases each. So how did that change? Well, Each one got doubled. We're ordering twice as much and twice as many in each order. And there we go. That's inventory stuff. So good luck on these. Ask questions. Please ask questions if you get stuck. And I think especially the first couple of problems on these homework ones are good at breaking down the problem into smaller pieces, which is hopefully going to help you guys. And then I would highly recommend doing the evens as well. I'm only assigning the odds here so you can check your answers, but I highly recommend doing the evens as well. And if you want me to look over your work, feel free to send me an image of your work on Slack. And then we can talk about the even problems as well. Get extra practice. All right. This will be on the exam. This will be the last section on the exam. We're not done with the section yet, but this is like the first half of the section. So yeah, I can guarantee there's going to be one of these problems. It's going to be tough. But if you do the homework and ask questions, you will be good to go. I can't pause the video. There we go.